Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. Hello again, our most developed student. My name is Confident and welcome to our revision session. And today we're looking at the revision of the mathematics N2 paper, and this is the paper that was written on the 15th of November 2022. And I did a review of this paper just to go through it in a few minutes, just to show you what the paper was about. If you didn't watch that video, just a review and a bit of comments on it, you can check the previous video on our 24-minute lesson. And in this session though, I'm looking at each and every question by question, and we are going through the paper. Now, without wasting time, let's look at this paper. And now guys, if you're joining us for the first time, it means that there is some stuff that you're always missing when it comes to the 24-minute lesson. Now, this channel is for the underdogs. What is an underdog? It is someone who says, I'm struggling and battling with my mathematics, but I believe given and enough tutoring or enough information, I can still make it and get the best mark. It is that person says, I'm struggling, but I know if someone can be patient with me, I will be able to pass my maths. So that's why I'm here. This channel is having you in mind. So if you are not subscribed, I will encourage you, subscribe now, because there's a lot of learning that you need to do on this channel. A lot of videos already uploaded, as well as more to come. Now, this is one of them where I'm looking at this paper, as I said. And if you wrote this exam, just see how you fared in that exam. It was a 3-hour paper, and it says you need to 2 sheets of graph paper. But now, if it is you preparing for your next exam, that is fine. Use this video. It can actually become very handy as you check out how the examiners are bringing these questions. So it's a 3-hour paper, as I said in the previous. I won't say much as I've looked at these instructions. Now with N2, you are not really told the number of decimal places that you can leave your answer in. So I'll say just like N1, you can leave them in 3 decimal places, which is the standard. But even if you leave them in 2 decimal places, you will not be penalized. Alright. So now let's look at the first question here. Question number 1. It says, Question 1, simplify the following without the use of a calculator. So the first part here was involving question 1.1.1. It was exponents, and 1.1.2 it was logs. So I'm just going to write this down so that I ensure that I capture everything. So you have here the 4th root of a squared, and this is b squared to the power of 6, and then you have what divided by a to the power of 5, b to the power of 7 times a to the power of -2 and b to the power of -4. I hope I captured this right. So this is what you're given. So let's do this on a fresh space. So this is what you're given here. Now, how do you approach this? There's quite a different ways you can approach this. But now, just to show you a few things here, because mainly is to understand the laws of exponents. That's why they say the question was saying here you need to simplify the following without the use of a calculator. So obviously they want you to use the exponential laws here. So just to bring in a few laws to you, if I give you, for example, if I say cube root of let's say x, this is same as saying bracket x to the power 1/3. So that cube root, or if I put an nth root of x, what it means is bracket x to the power, but don't look at this, it's 1/n. You see that? So this nth root becomes 1/n as an exponent. So the same thing with that 4. So if it was 4th root of what? Of whatever inside, is same as whatever is inside to the power 1/4. So that's the first part that we're going to apply there. So if I apply that there, what I will have then will be in a bracket here equal to bracket, it will be a to the power of, all right, now I'm going to apply two things. Let's work on two things so that we do two things once. If I give you a to the power of m, at the same time b to the power of m, and then everything to the power of n, so what does it mean? This n becomes a to the power of m times n, b to the power of m times n. So the n will multiply the m twice. You see, you are multiplying. So the same thing that I'm going to do here. Look at this. I've got 6. We'll go and multiply the 2 and multiply the 2. And then at the same time, I'll use the 1 for the nth root. So I'm going to do two things at the same time. So it will be what? It will be, I'm going to use a different part. It will be 2 times 6. And then I've got b as well as what? 2 times 6. See that? That's what I'm trying to say. So that's the part. And then don't forget when I said the nth root. So when you close that bracket, that 4 becomes 1 over 4. Are you with me? That's the main part. Maybe if I can write it with a different color just to kind of show you what I changed there. That is that. And then when you do that, you are dividing that by the normal. Okay, again, let me not waste time. Just as 3 marks. When you are multiplying, remember the laws. I'm using the laws here. If you're given a to the power of m times a to the power of n, what do you know? If the base is the same and there's a multiplication sign, it's a to the power of m plus n. So you can see that there is multiplication here, but the key part, what you need to understand is a to the power of 5, there is a times there, and there is a times there. So you can even put a multiplication sign between those, so that it becomes a to the power of 5 and then plus negative 7, because the a and the a is the same, as well as b to the power of 7 plus negative 4. Now you say, but you can put a plus or minus. It's okay to put a bracket like that, and it's okay to put a bracket like that. You see, so what I was doing is trying to work this thing and use the laws at the same time. Now here you will have a to the power of 12, b to the power of 12, everything to the power of 1 over 4 all over. Now a to the power, look at this, 5 plus minus 7, with the calculator you'll get a negative 2, and b, and then 7 plus minus 4, you'll get a 3 here, if I'm not mistaken, with that. So let me just check again if I did this. A5 B7, A5 B7, which is correct, and a negative 2 b negative 4. So yeah, I did write it right. So now when you are doing that, I see now where I'm actually making an error here, because look at this. I'm supposed to say this negative 7, it's a5 plus a negative 2, not supposed to be negative 7. Are you seeing that? Just correct that one. So that in here is going to be 5 plus minus 2 is going to be a to the power of 3, and here 7 plus minus 4 is b to the power of 3. All right, and then after that you can then apply same thing that I did previously. This 1 over 4 is going to multiply these exponents, so you multiply with that. Are you with me? So what does it mean? It means it's going to be a to the power of 12 times 1 over 4, b to the power of 12 times 1 over 4, and then it's all over a to the power of 3 and b to the power of 3. Then you can now simplify this to say there 12 divided by 4 is 3, and there is 3. So what do you have? You have got a to the power of 3, b to the power of 3 over a to the power of 3, b to the power of 3. which is equal to, you can literally cancel out. The top cancels the bottom, which is 1 over 1. The answer is simple 1. You're seeing that? So that is the first part there. Now, as I said, there are quite a number of options that you could have done here, quite a number of approaches. It's up to you how you wanted to do it. Some they might do it differently, and well, there are many different possibilities, just to say, but I'll just leave it here without confusing you. But the main part that they wanted to check that you are aware of was that fourth root, as well as being able maybe to simplify the bottom. So someone can actually want to take these a to the power 5 to the top is still fine, where you would take this to the top using that rule which says 1 over a to the power of m is equal to a to the power negative m. So that in here, if I can just use a different color here to say from here, that you will have in such a way it will be a to the power of 12, b to the power of 12 bracket 1 over 4, right? And then because you want to take the other part to the top, it will be, I'm working backwards, the a to the power of 5 will be a to the power of negative 5, and then it will be b to the power of negative 7 times a to the power of negative 2 now becomes a to the power of 2 times b to the power of 4. Whatever was positive becomes negative. Whatever was negative becomes what? Becomes positive. These are other ways, so that you have something now without a fraction. Then you can then move on to say it's a. Remember, this 4 was cancelling here to become 3, and this one is making this become 3. So you can now focus on the a's to say you have got a to the power of minus 5 plus 2 and plus 3. I think that, and then you've got b minus 7, you're using now the first law, plus 4 plus 3. And then if you look at this, you've got a minus 5 plus 5, which is 0, and b minus 7 plus 7, which is 0, and then any number to the power of 0 is equal to 1. So this was another way, but at the end of the day it was going to lead to the same answer. All right, so let's look at the next one. Simplify again without a calculator. You're given this part of logs. Now let me write this, let me erase that and come back to this one. Logs again is not really complicated, you just need to know what you're doing. So here we have got bracket log in base 3 of 27 squared plus log in base 8 1 over 64. I just want to write this, you just need to be careful how you write this. So a log in base 8 of 1 over 64 and then to the power of 3, which is to the power of negative 1. Now let me show you what most students do when they're writing logs in error. This is what they do. They write like this: log in base 3 of 27 squared. See, this is wrong because it says if the number is 3, there is no more base. Or if they're writing log in base 8 of 1 over 64, you see, it says if 64, now 1 over 64 is a power. So all these are wrong ways of writing. You must write it like this: log 8 is at the bottom, and then if it's 4, it must be in line. I think that. So you just need to know how to write this properly. Don't forget, with the logarithms, you just need to be comfortable in writing logs. So let's look at this. If I bring it in here, again, we are using laws of logs. Now, what is the law that I'm looking at here? The first part of the law, let me see again if this is done properly. Okay, I see that. to the power of this. Alright, the first thing I do, they say don't use a calculator, but guess what? Let's take a calculator and actually let's find where does this thing lead. So let's have a calculator. So you have got that first bracket and you've got that first bracket, which is log in base 3 of 27, and then you have got squared, right? And then plus you have got log in base 8 of fraction 1 over 64, and then I think there, let me just see, but I don't know where is that 3, that power 3. I think there is a bracket also here, but I'll check it. Okay, let me just put a 3 there. I think the cube is there, and then you close the bracket, and then you've got -1, but I'm here to check that. -1 equal to, I'm getting a 1. I just need to be sure of this. So what I'm getting at, I'm getting a 1. Let me just check this thing here. Yeah, that was correct. So it's me who didn't put this bracket here, so it gave me a 1. So there is a bracket here that I need to put. There is a bracket here. Alright, so that the plus sign is actually like this. So now look at this, it gave me a 1. That's the answer that I'm getting here, to say how do I work towards a 1. So we're gonna use a couple of rules here. The first one is understanding what is 27. Now there is a law which says log in base of a of a to the power of m. Let me use this law, it will cover quite a number of things, is equal to, now this m will go this side so that it becomes m log a of a. See that? Which is equal to, it doesn't finish there. When the base and the number are the same, look at this, the base and the number, you have got m times 1, because that is 1, which is equal to m. So when you've got, for example, log base 2 of 2, the answer is simple 1. Are you getting that? So the same thing is going to happen here. Look at 27. 27, you need to understand that 27 is, we can write this 27 like this. I just want to limit my calculations here. 27, so that when I'm writing it, you'll understand where it's coming from. Now 27 is same as saying log base 3 of 3 to the power of 3, because 27 is 3 to the power of 3, right? Which is equal to 3 log 3 to the power of 3. This is what I have for 27. So if I do it, it will be 3 log 3 of 3, and then don't forget that bracket squared, remember that, plus same thing when I come to the part of what is that, 1 over 64. Look at this. If I give you laws of logarithms again, if I say to you, you have got log in base a, let's say of 1 over a to the power of m. Did I write that correctly? Let me make it clear for you. I'm saying you have got log in base a of 1 over a to the power of m. Now you can take this to the top, remove that fraction, it becomes log in base a of a to the power negative m. You see now, then when it's negative m back again, take this negative m to the other side, it becomes minus m log base a of a, which is equal to minus m times 1. So that's what I'm going to do here. What is 64 and 8? You need to understand 64 and 8 is same as saying here it's log. Let me also limit my calculations here. So it means when I'm using the same thing here, when it comes to 1 over 64, this one, just to limit my calculations, so I've got log in base 8 of 1 over 64 is equal to log
in base 8 of 1 over 8 squared. 64 is 1 over 8 squared, which is equal to log in base 8 of 8 to the power negative 2. This is when I'm taking it to the top, it becomes negative. So that's the same thing here. I'm gonna have 8 to the power negative 2, and then bracket, I have got what? I've got power 3, and then close the bracket is negative 1. Alright, continue. This is equal to, so this is equal to, now from here, remember it's 3 times 1, and then it's what? 3 times 1, this is squared, plus, now as I said, this negative 2, you can drop it, right? So it will be, when you take this negative 2, you can literally drop it. So it will be negative 2 log base 8 of 8 bracket cubed, and then to the power negative 1, which is equal to, now when you do that, 3 squared. What is 3 squared? This is same as 9, and then you have got plus, and then we have got what? 9 plus, you've got again negative 2, 8 and 8 gives you a 1 in bracket to the power of 3 in bracket negative 1. Are you seeing that? Which is 9. Now this is same as minus 2 to the power of 3. So if you say negative 2 to the power of 3 with the calculator, I have got here negative 2 cubed is equal to negative 8. So 9 minus 8 to the power negative 1. What is 9 minus 8? 9 minus 8 is 1 to the power negative 1, which is equal to 1 to the power negative 1 is simply a 1. You can check it with the calculator. It's simply a 1. So that's how this confirms, it confirms that the answer that we're getting is still correct. Again, with it, different ways of doing it, yes, there is quite different approaches that you could have done here, but let me just limit it to that. So this was that. How many marks is 3 marks? Now 1.2, it says you need to solve for x. If log base x of 9 plus that minus log that is equal to 3, 4 marks. Okay, it's a good question. And 1.2, I don't think it was actually difficult, but it's a good question. Look at this. It says log in base x of 9 plus log in base 3 of 1 minus log in base 4 of 1 over 16 is equal to 3. So we need to solve for x. The good thing about questions like this, when you're solving for x, you can literally test them. So every time you're solving for x, be able to test. But a few things here, there is always some rules or some laws. The first one is this one, where you're given log in base a of 1, any number whatever, this becomes 0. It doesn't matter as long there is log 1. Log 1 is equal to 0. So that first part here, this is actually 0. They'll give you a mark for that. And again, there is the part that we did log 4. Now 16, 1 over 16 is same as saying log 4 of 1 over 4 squared, you see, which is log 4. Now take this to the top, it will be 4 to the power negative 2. That's the first part. So we continue and saying this is log base x of 9 plus 0. They'll mark you that 0 minus log in base 4 of 4 to the power negative 2 is equal to 3. They will mark you that because that is where it's coming from. Now, careful now. This negative 2, remember it goes this side and multiplies. When it goes this side, it just goes there and multiplies. So there will be 2 negatives. So what we have got log base x of 9 is equal to, minus minus, so there is the first negative there, and then you've got bracket negative 2 log base 4 of 4 is equal to 3. So two negatives, negative and negative, it gives you what? It gives you a positive. Remember that. So you have got log in base x of 9, and then plus 2. Now log 4 of 4, we say this becomes 1. You can test it with the calculator, but it multiplies, is equal to 3. So 2 times 1 is 2. It will go this other side. It's positive. When it jumps the equal sign, it will become negative. So that you have got log in base x of 9 is equal to 3 minus 2. Are you with me? Then you continue now. Log in base x of 9 is equal to 3 minus 2 is 1. Now how do you simplify this? Now pay attention. It's not difficult. It's not difficult. This is what you do. If you are given log base a of m is equal to b, look what you do. You take a as the base, which is still a base here in exponential. It's a. This becomes the power. Okay, a to the power of b is equal to the number m. That's how you convert log to exponents. So what you're going to do here, you take x, which is the base, it will still become the base, to the power of what? 1 is equal to 9. That's what you simply do. So x to the power of 1 is equal to 9. And then from there, what is x? What is x to the power of 1 is x. Therefore, simple, x is equal to 9. That's the answer that you get there. Alright, but as I said, with solving for x, the good thing is always test it. So you go to the original here, and where there is x, you put a 9. And then from there, what you do is you check if the left hand side balances the right hand side. So log base 9 of 9, which is like a 1, and then plus log base 3 of 1. Remember we said our x was 9, that's why I'm putting a 1 there, minus log base 4 of 1 is what? It's 1 over 16 equal to what? Equal to 2. Why am I getting a 2 there? Okay, let me check if ever there is an error I made. It's log base 4 of 1 over 16. I think I see the error. I put everything inside this. This must be outside. Look at this. The problem there is the bracket. So it was supposed to be like this. Okay, I see now. This is supposed to be a 1. Okay, like this. Log 3 of 1 is supposed to play forward and then say log base 4 of play forward of what? 1 over 16. I think that was the error there. Is equal to, again I'm not getting that. Is it supposed to be plus? Supposed to be a minus in between here. But you just test it because I'm just doing a lot of things here. Let's try it again. It's log base 9 of 9, yes, plus log base 3 of 1 minus log base 4 of 16 equal to, I'm getting a 3. So you just need to be sensitive how you punch this. But oh, of course, it's correct. No, that was how many marks? That was 4 marks. Let's move on to 1.3. You need to solve for x if this. How many marks was 3 marks? Also not, it was, the first questions here were standard algebra, so you just needed to be careful. So you've got 2x plus 1 over 16 to the power of x minus 2 is equal to 256. I think there were two approaches here. You can focus on using 4 or 2. Let me try by using 4 just to show you. If I was focusing on 4 here, what do I have? If I was focusing on using 4, what you need to do, look at 64. If I say 4 to the exponent 3, you need to know such numbers. You see, 4 exponent 3 is 64. 4 squared is what? Is 16. What about 4 to the power of 4? is what? 256, you see? So here you can actually see that this could be written as a multiple of, as 4, exponent of 4. So if I can use that, it becomes then much easier for me to simplify. Look at this. I can then say 64 is 4 to the power of 3. But now, how to write 2x plus 1? You open a bracket and you say 2x plus 1. That's how you write that. So that the 3 is the one multiplying over. 16 becomes 4 squared. Again, open a bracket. X minus 2. You see how you do that? Is equal to, on this one, we say it becomes what? 4 to the power of 4. You just expressed everything in terms of 4. So then it's up to you how you want to do it. Remember, as I said, open this bracket so that you've got here, for this can open and this can open as one way, and then also here this can open and this can open. So what you have got 4 to the power of 3 times 2, it's 6x. 3 times 1 plus 3 over, there are quite a number of ways. 2 times x is 2x, and then 2 times negative 2 is negative 4, is equal to 4 to the power of 4. Then I think what you can do, this is over 1, you can cross multiply here. The top multiplies the bottom here. Since it's an equation, the top multiplies the bottom. So what you have, 1 times the first one, it will be 4 to the power of 6x plus 3 times 1, it remains as is equal to 4 to the power of 4 times, you can put a dot or you can put a times, 4 to the power of 2x minus 4. Are you with me? Now, laws of exponents, when it's like this, when you multiply, remember you add. So you've got 4, 6x plus 3 is equal to 4, then you add the exponents, 4 plus 2x minus 4. That's where now you can see that 4 minus 4, it cancels, right? So what you have got 4 to the power of, let me maintain my pen, as 4 to the power of 6x plus 3 is equal to 4 to the power of 2x. Are you with me? And then if I can continue with this, the bases are the same, equate the exponents. Now what law am I using? I'm using this law which says here a to the power of m is equal to a to the power of n. Very important laws of exponential equations. A is a, therefore m is equal to n. The moment the bases are the same, you equate the exponents. So we're doing the same thing here. I can now say therefore here the exponent on top, which is 6x plus 3 as a whole, is equal to the other side, which is what? Which is 2x. I see that. And then it's up to me now to solve this. Take 2x to the other side to join 6x. It's positive on the other side, it will become negative. So 6x minus 2x is equal to, the 3 is positive, it will become what? Negative 3. What is 6x minus 2x? 6 minus 2 is 4x, is equal to negative 3. Then you divide both sides by what you don't want with x there. You don't want that 4. So you can see now the value of x. X is what? X is equal to negative 3 over 4. But guess what? Whenever you're solving for equations, you can test this. But I'm going to do different ways on here. But let's test this first to see if we're right. So x is equal to what? Negative 3 over 4. So you come here on the original and you do the same thing. You input the value of x to say if this is 64 to the power of x is 2 times negative 3 over 4. Say that, do it as is, plus 1 all over 16 to the exponent of negative fraction 3 over 4, that is your x, and then it's minus 2. It must give me 256. There it is, you see. So the answer is correct. So when it's like this, you are 100% sure the answer is correct. What if I chose instead to use, as I was saying, to use 2. Now if I was to use 2, if I can use 2, now look at this. What I need to know is what is 64 in terms of 2. I think it's 2 to the exponent of let's say 16. 2 to the exponent of 4 is 16, and 2 to the exponent of 6 is what? It's 64, and 2 to the exponent of 8 is 256. You see, so it's 4, and then let me do it again, is 8, and then 2 to the exponent of 6 is 64. So you can write this actually like this, to say this was 2 to the exponent of 6, then bracket 2x plus 1, remember what I did previously, over 2 to the exponent of 4, and this x minus 2 is equal to 2 to the exponent of 8. Again, there is a different way you can approach this thing here. You can actually say, use this rule. Remember I told you about the rule to say 1 over a to the power m. If you want to take it to the top, it's same as a to the power negative m. So you can do the same thing here and say, using this rule, take 2 to the top, you put a negative on that 4. So what will it become? It will become 2 to the power, you multiply that 6 times 2, remember you open the bracket there, and then what do you have? You have got 12x and then plus 6 times, then take this 2 to the top is minus 4, and then it's x minus 2. You see what I've done is equal to 2 to the power of 8. You could have chosen that. You could have maintained 2 the same way, but you could have done it the other way also. It's still fine. Then you've got now 2 to the power of 12x plus 6 times 2 to the power, open also this bracket here, is minus 4 times x is minus 4x, minus 4 times 2 is plus 8, minus 4x. I must maintain the x here. Minus 4 times negative 2 is plus 8, is equal to 2 to the power of 8. Then I'm going to use the first law. 2 is the same. This says a to the power of m times a to the power of n is equal to a to the power of m plus n. I'm going to use this law because it's 2 and 2. So what does it become? It becomes 2 to the power of 12x. And then, now since I'm adding, it's plus negative 4. I'm collecting like terms already. Negative 4x. I'm adding that, and then I'm adding plus 6 plus 8 is equal to 2 to the power of 8. Then when you add 12 plus minus 4, it means 12 minus 4, which is 2 to the power of 8x. 12 minus 4, it's 8x. And then 6 plus 8 is 14, is equal to 2 to the power of 8. And then when we have done that, same thing that we did here, I'm now equating. I'm using the same rule here to say 2 and 2, which means 8x plus 14 is equal to 8. So 8x is equal to 8. Take 14 to the other side. It's positive. Cross the equal sign becomes negative. So 8 minus 14. So 8x is equal to now 8 minus 14. It becomes 6, negative 6. Divide by 8, divide by 8. And then what is the answer then? Now 8, there we go, to say x is equal to 2 into 6 is 3, 2 into 8 is 4, which is negative 3 over 4. Same answer that we got in the previous one. See? So that is in a way, it's the same way, just that I approached it differently. I used 4 and I used 2. It's about understanding your laws of your exponential laws. All right. Let's move on again to the other one, 1.4. All this was basic in a way. There wasn't much of algebraic new things, but it was basic. 1.4 is 3 marks. Given this, 1.4.1, make h the subject of the formula. So this is about the subject of the formula. Also not complicated. You have given s is equal to pi r, and then you have got 4r plus 2h. Seeing that. So now what they're saying is you need to make what? You need to make h the subject of the formula. So I don't think it's also complicated for you to make h the subject of the formula here. It's not a complicated problem. H. What you need to do is, first of all, we need to open up this bracket. So when you're opening it up, this multiplies and this multiplies. That was one way you could have done it. Otherwise, I'll show you. So this times this, so you have got s is equal to pi r times 4 pi r, which is 4 pi r times r becomes the r squared. You see that? Plus pi r times 2h, which is 2 pi, which is 2 pi r h. Are you with me? Then remember our interest is h. Take this 4r to the other side. It's positive, it will become negative. So it's s minus 4 pi r squared is equal to 2 pi r h. I think that we're interested in h. So now divide everything by what you don't want. 2 pi r, divide by 2 pi r. But what you do on the left, you do on the right. This is 2 pi r. Then what do you have? Therefore, h is equal to s minus 4 pi r squared all over 2 pi r. You are also allowed to say it like this. You are also allowed to say it like this, equal to the s over, that s is over 2 pi r minus 4 pi r squared over 2 pi r. Meaning the 2 pi r is affecting that and is affecting that individually. Then you can have h being s over 2 pi r minus, now 2 into 4, it's 2. The pi cancels the pi and the r on the squared is 1, so it's minus r. So your answer can be here, it's correct, or your answer can just end up here. Your answer can end up here, they'll still mark you right. That was one way. The other way I suggest you could have done here, depending if you want to maintain, let me duplicate this. Let's say you wanted a separate way of approaching this. There is a separate way you could have done. What you could do here, for example, I will choose to say, let me already here divide by pi r. So I don't want this bracket out, so I can divide by saying s over pi r is equal to pi r 4r plus 2h and then over pi r, meaning I don't want that. You see that? So that I've got s over pi r is equal to 4r plus 2h. I mean 2 pi. 2h is actually not pi, it's 2h there. So this is h. So you see, that's a way of opening the bracket. Take this to the other side. It's positive, it becomes negative. So it's s over pi r minus 4r is equal to what? Is equal to 2h. I don't know why I'm writing it as 2 pi. So I want to remain with what? With h. So 2h over 2 is equal to s over pi r minus 4r divided by 2 also. What you do on the left, you do on the right. You see that? Then it's up to you how you want to do it. Again, I told you this 2 affects that and that because of the negative sign. So it's s over pi r over 2 minus 4r over 2 is equal to h. So if you left your answer here, they can still mark you here. They can still mark you here to say you've got h, but it's more professional to take it further here. This 2 goes there so that you become s. It will become s over 2 pi r minus 2 into 4, it's 2 minus 2r is equal to h. Look at this and look at this. Is it making sense? H is equal to s over 2 pi r. You see that minus I'm getting, okay, here I think, you see, that's good sometimes to do these two things. I'm getting 2 on the other side, so there is a 2 here. Look at this, 2 into 4, I say 2. I don't know why I wrote R. It's 2R, not just R. So that helps now, because you see, I've managed, on this other one, I managed to remain with the 2. So the answer is that. And then the next question says, calculate the value of h if R is 2,45, S is 14,7, correct to 3 decimal places. So R is 2,45. So what you do here is you continue now to say that is question 1,4.2. So I can continue with here, say 1.4.2. So S is equal to what? 149,7. So I can come here and say 149,7 over 2 pi, and the R I'm getting, they said R is what? 2,45. So you put a bracket and say 2,45. I sing this minus 2 bracket 2,45. So this is substitution, and then you get h. Wherever there is the value of R, you put R. Wherever there is the value of S, so that's what you're doing. So it's 149,7. Here you just need not to make errors. Shift pi and then bracket 2,45, and then minus 2 bracket 2,45. I don't know why I'm doing it down there. It's supposed 2,45, play forward, and then it's minus 2 bracket 2,45, like this. Then you get your value of h, which is, as I said, it's up to you, 2 decimal places or 4 decimal places. I'll go for 2 or 3. Shift setup, that's how I round off, 6 to 3 decimal places, 4,825. So I get h is equal to 4,825. There are no units, so I leave it as is. Alright, so this was how many marks? 2 marks. Not bad. Now 1,5. I think question 1 was mainly on algebra, but not really some questions out of range. It's something that you can relate to. So this is the third mark, 3 marks. 1,5 says solve for x in the following equation. Look what they did. They give you this, and this question is what? 20x squared plus 9x is equal to 18. See, there are different ways you could have solved this, but I don't want to spend much time on this. The simplest one I'll always encourage students is to go to your back of the formula, and what do they give you? They give you the Pythagoras. Not the Pythagoras, sorry, the square root. The one for solving such questions is the square root formula. This one, the roots. So there is the formula. You remember this one? So the formula for the quadratic equation. I'm mixing it with Pythagoras, sorry about that. So look at this. So the formula, what does it say? It says x is, let me write here, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Very important formula when you're solving this. But now, this is not standardized. There is a standard form of this. What is the standard form? It says ax squared plus bx plus c is equal to 0. First, you must identify that this is not standard. It's not the right way. So what does it mean? It means, you see, if I write here, I'll write it as 20x squared, which is fine, plus 9x is fine. But you see, I've got plus c. That's why I must take 18 to the other side. From positive, it will become negative 18. You see this? Then equal to 0. That's very important. That's why at that stage, you can see my a. See that? So my a is equal to 20. And you can see when I cut here in x, you can see my b with the sign. My b is equal to 9. And then your c is the one remaining. You can see that. Your c is equal to negative 18. It's a very good technique that you need to get used to. Then I can now use the formula to say x is equal to minus b, so it's minus bracket b is what, 9 plus or minus square root of b squared, which is 9 squared minus 4. My a is 20, my c is negative 18, and then it's all over what, 2, and then my a is what, my a is 20, like that. Then with this I'm able then to finalize to say what is my x, and then you can then use the calculator here to say negative 9 bracket 9, and then you've got plus, start with the positive, square root of 9 squared minus 4a was 20, and c is negative 18. You see that, all over 2 and then 20 equal to, first one x is 3 over 4, and then you go back, so x is 3 over 4, and then the other one x is negative 5 over 6, so x is negative 6 over 5 I think, and then x is equal to 3 over 4. So you just write those two answers, then you test the answers to say, check the first one, if x is negative, I think it was negative 5 over 6, not 6 over 5, so negative 5 over 6, you take it into the original here, it must give you 18. So if I come with the calculator again and say in here 20 bracket negative 6 over 5 squared plus 9 bracket negative 6 over 5, alright, equal to, you see I'm getting 18. You can try the other one, it was 3 over 4, so you can try that and say, okay, if it's it was positive 3 over 4, and then again on this one you delete and say positive 3 over 4 equal to, again it's giving it left hand side, right hand side. So that's how you test these guys, and it kind of gives you the 21 marks that we are working on. Alright, now let's look at question 2. Says fully factorize the following expression.